This is question 43 from section 8.3, and I'm not going to go through the entire problem, but we can at least kind of get started to sort of see what's going on. What we have been asked to show in this problem is that the vector equation r minus a dotted with r minus b equals 0 represents a sphere, and then we've been asked to find the center and radius of the sphere. So I'm just going to go ahead and say we've been given this equation. I'm just going to start figuring out what this means. So each of these, because we're talking about subtraction, each of these represents a new vector. And I'm going to get that new vector by taking my r vector and subtracting my a vector. We say that we do this addition or subtraction component-wise, meaning I'm going to subtract first component minus first component. So my r minus a vector, the new first component here, is going to look like x minus a1. Now I'm going to subtract my second component, so I'll have y minus a2. And subtract my third component, so z minus a3. So this vector is my r minus a vector. That, we're now doing a dot product with this new r minus b vector. So to write that out really quick, my subtracting first components and first components, got x minus b1, y minus b2, z minus b3. Now there are lots of different ways to write vectors. I'm sticking with the notation that so far has been presented in our book in this section. When we do the dot product, just like if I was doing addition or subtraction of vectors, when I do the dot product, I have to match up component to component. So when I'm doing this dot product, I'm now taking the first component and multiplying it by the first component. So we're going to get x minus a1 times x minus b1 plus, so we're adding up dot product. The way we take that is that we multiply the components that are in the same place together and then add between our components. So my second components here, I've got y minus a2 times y minus b2, and then our last component, z minus a3 and z minus b3. That's our dot product. Now, in order to show that this is the equation of a sphere and to find the center and radius, I don't have a shortcut. I really think that you would have to multiply each of these pieces out, and then you're going to end up completing the square to find the center and radius. So it won't be pretty, and maybe we can just look at one of these three pieces in terms of completing the square. So let's just take this front piece with the x's for a minute. If I distribute that out, I would end up with x squared minus a1x minus b1x plus a1 b1. I can take these two pieces, and because those are my two x pieces, I can write that as x minus a1 plus b1 x plus a1 b1, and then to this I'd be completing the square, meaning I'm going to take half of this component so that this would become x minus a1 plus b1 over 2 squared, and then to finish off completing the square, I know that in doing this I've added the a1 plus b1 over 2 squared, so I now have to subtract it back off. and we still have that plus A1, B1. So you'd have to go through and do this for the Y's and for the Z's, but the process will be really similar. So I already know that in terms of where the center of my sphere is, the X coordinate for the center of my sphere is at A1 plus B1 over 2. And then all of this stuff, when it gets moved to the other side of my equal sign, remember it was equal to 0. When I move all of this stuff over, combine that with the Y's and the Z's, that's going to give us our radius.